Okay, this is my $1,000 engineer challenge to any engineer that can prove to me that my reactions, the bottom of concrete at the wall system, is not in compression. So this would argue against ACI, wouldn't it? That tension is in the bottom of the pads. This would argue against your basic training, your basic education. So $1,000, it's one directional. If you lose, you don't lose a thing. It's not a bet. It's not a bet. This is a challenge. And if you win, I give up money. So there's no, it's not a bet. So betting is mostly illegal. It needs to be sanctioned by your states. But this is just a $1,000 educational challenge. You educate me and show me where there's no compression over there, where I show it to be in two of my videos previously, in a few videos. And then you'll understand, because you'll lose, then you'll understand, if there's compression there and there's tension at the top, there's a slide plane created right about here somewhere. And usually that slide plane, if you will, one going one direction, the forces, and the other going the other way, indicate themselves as a fracture there upon the rebar, which everyone in this new schooling, which I follow a ton of it on YouTube, where they post their videos of testing, they all call it a shear fracture. A shear fracture as in, look at the top screen here. And they call that, because of the deflection, that this is a shear fracture because it goes over to the wall. If you look at these damn imagery better though, when you look at them, you'll see that the fracture may appear like this, but then it also turns this direction and goes down the rebar. And that's that shear plane. The force is going this way, and the force is going that way, being resisted, and they're resolving themselves there upon that rebar that goes into compression or tension. However, the separation of the distance is 9 inches, behaves differently than 12. And if you shear link them together, they'll behave, shear link them. If you use stirrups together, shear links is something I'm trying to push. Stirrup them together, you'll get a different crack pattern. All right, so that's not the challenge. The challenge is to show me for $1,000, one directional, I give to you. Show me there's no compression down here when this deflects. Show me there's no compression that results down there when it deflects. We're talking out to failure. All right, there you go. $1,000 challenge for the taking. Engineers only. Come on. The reason why engineers only, because it's a serious challenge. And I want them to be able to prove to me that I want them to be able to, by default, they'll lose, and then just educate them. I'm trying my best to wake up the world community of engineering with that this is the critical point, and it's being ignored. It's being ignored. It's by the columns. It's by the walls. All right, it's by all deflection this is being created. The compression is being created on the bottom part. I have more for this, but a little hint, it would be, as you can see, I'm quite irritated with this shit. This punch shearing idea. I try to troll people with it and everything else, and I get no, intellectual challenge that's correct. I want you to think of the column heads again. Or maybe I should just let this video go with that, with the $1,000 challenge. I'll give you a hint. Critical shear area, column, and that's your tributary area. So post hoc, propter hoc. Just because one is not tied to the other, just because it appears to be coming off the edges, does not mean the edges are the weak section of this. It just means they're more overloaded than the rest. They're more overloaded than this section. It doesn't necessarily mean that the corner is overloaded. All right, before I start cursing, I'm hanging up. Bye.